Good morning, calculus class. Would you expect me to be anywhere else today after the last class? Good morning. So today I'm going to teach you how to take limits using a new rule called L'Hopital's rule. L'Hopital was a French mathematician. All right, so let me share my screen. I'm going to turn off my camera. And here's today's PowerPoint. And it is in honor of this stupid wedding that I have to go to today. So Calculus 1, April 27th, although I think the 28th, I made slides yesterday. And so today's learning objective. I will learn L'Hopital's rule to find limits, and I will use L'Hopital's rule to find limits. There's Martin Simpson. All right. So suppose we have to take the limit as x approaches 0 of sine x over x. Well, we know that the sine of 0 is 0. So we would end up with something that looked like 0 over 0. So we see the limit of the numerator equals 0. The limit of the denominator equals 0. So what do? Well, let's call the numerator f of x and the denominator g of x. And did you know that if the limit equals 0 over 0, then the limit is also equal to the limit as x approaches 0 of f prime of x over g of x. Hence, it's the limit as x approaches 0. The derivative of the numerator is cosine x. The derivative of the denominator, because we're looking up here at our function, of the denominator equals 1. So now it's the limit as x approaches 0 of cosine of x over 1. Well, the cosine of 0 is 1, so we get 1 over 1 equals 1. How about that? All right, there's the graph of it. So we could see that the limit as x approaches 0 equals 1. And here's the graph of cosine x over 1. And we see that the limit as x approaches 0 of that is also 1. All right, so what is L'Hopital's rule? Suppose f of x and g of x are continuous. Sorry about that. Suppose f of x and g of x are continuous and differentiable at a. Now suppose the limit as x approaches a of f of x over g of x goes to 0 over 0, or infinity over infinity, or negative infinity over negative infinity. Then we could use L'Hopital's rule. We take the derivative of the numerator and the derivative of the denominator, and then we take the limit. Now, keep in mind, this is not the quotient rule. Do not use the quotient rule. It's L'Hopital's rule. So suppose we have the limit as x approaches 0 of e to the x minus 1 over x squared plus 3x. Notice the numerator is 0 when we plug in 0. Plug in 0 in the denominator, we get 0. So substituting gives us 0 over 0. But when we take the derivative of the numerator, we get e to the x. When we take the derivative of the denominator, we get 2x plus 3. So now we have 1 over 3. So if we substitute, we get 1 over 3. And that's our answer. Just look at that. All right, please look at the shadow of that bride. All right. Now, got one with infinity. So then when we plug in infinity, the numerator goes to infinity, the denominator goes to infinity. So f of x equals 3e to the 3x, g of x equals, f prime of x equals 3e to the 3x, g prime of x equals 9e to the 3x. That's if we take those derivatives. So we get 3e to the 3x over 9e to the 3x. And notice, e to the 3x's cancel out. So we're left with 3 over 9, which is 1/3. So the limit is equal to 1/3. And got a little bridezilla going on there. And that's pretty much it for L'Hopital's rule. I'm going to go to the whiteboard now and do a couple of examples, but sometimes you're going to have to use L'Hopital's rule 2 or 3 times in the same problem. That's number one. And number two, you really got to know your trig functions. So you might want to have Desmos on hand to check your answers and to evaluate the trig functions if you need to. So let's go to the whiteboard. I want to show you this one. The limit as x goes to infinity of 2x squared minus the natural log of 2 over x over 3x squared plus 2x. Now I'm going to do a little sidebar. Negative natural log of, negative natural log of 2 over x equals, we'll use the laws of logs, throw that negative up there. 2 over x, I'm sorry about that, is equal to the natural log of 2 over x to the negative 1, which is the natural log. Why am I keep writing LIN? The natural log of x over 2, because to the negative 1 means just take the reciprocal. All right. So this is equal to limit as x goes to infinity of 2x squared plus the natural log of x over 2 over 3x squared plus 2x. Now, we still have infinity over infinity, but it makes it a hell of a lot easier to take the derivative of the numerator. So the derivative of the numerator is 4x plus, it's the derivative of the inside over the inside. So that would be 1/2 over x over 2 over 6x plus 2. I'm going to scroll down a little bit. All right. So in order to simplify that complex fraction, we change the main division bar to a division sign. And we get 4x plus, the 2's will cancel out, technically 1 over x over 6x plus 2. That's the limit as x goes to infinity. Now, we're still going to get infinity over infinity. Oh, my goodness gracious, excuse me. All right. So we got to take L'Hopital's rule again. Got to do a second L'Hopital. Going to do L'Hopital's rule again there. Okay, so now we have the limit as x goes to infinity. The derivative of the numerator is going to be 4 plus negative x to the negative 2, because I thought of that as x to the negative 1 over 6. Okay, and let's take a look at this. Now, as x approaches infinity of this value right here, negative 1 over x squared, that's going to go to 0. So that'll drop out. We just have 4 over 6, which of course is 2/3. So here was an example where we had to use L'Hopital twice, and it worked out just fine. Now, there's another one where I'm just going to give you a little hint. You're going to see something like something to the effect of 2 sine of pi x cosine of pi x. Do you want to say good morning? Yeah, let me, guys, I have to turn my camera on for a second because somebody wants to say good morning to you. Come on over here to the farm. Okay, why don't you introduce yourself?
My name is Vera Matthews. I'm my dad's daughter. Hello.
And then who you with? Let's see if we get him in there. Eddie, you want to say hi? All right, sorry about that. All right. So as I was saying, you might have 2 sine x, sine pi x cosine of pi x. Now, that's called the double angle identity. So that's equal to sine of 2 pi x. So that'll make your life a little bit easier when you're employing L'Hopital's rule. It just makes it easy, a heck of a lot easier to take the derivative. All right, so now I think you have enough information to use L'Hopital's rule successfully on tonight's homework. If you use I want you to have the answer key nearby because I did write some notes, like some of the steps. I actually put a little annotations on a few of the steps to help you out a little bit more. All right, Professor Ken, let me stop the share. All these scary wild animals, I'm terrified. All right, so this is Professor Ken signing off. Have a great weekend. Oh, I guess I should take you over. There's 2 assignments today, and I'm not ashamed. So if we go to April 28th, you do have problem set 37, which might take you a minute to do, a long minute. Then we have an end of course essay, which isn't due until Monday night. So problem set 37 is due Monday morning. End of course essay is due Monday night. So what does that mean if you click on this? All right, so there's 3 parts to this essay. You may probably have noticed that, I hope you have, that the quote at the end of my email says, "Let your goodness be your greatness and kindness counts." So first part of the essay, pick one of those quotes or both of them. Discuss how those quotes were pervasive throughout the course to you personally. In what ways have these quotes been manifested in the course to you personally? In what ways do these quotes impact you, if any? If they don't, then you can talk about how they don't impact you. And do not generalize. I want you to be extremely specific. Second part, discuss what you will remember most about this course and use details. And last, if someone were to ask you to explain the nature of this Calculus 1 course, not just Calculus 1, but this particular Calculus 1 course that you took, how would you respond? So 2 spaces, double spaced. Don't spend a lot of time on it, 30 minutes at the most. Don't worry about citations, grammar, spelling. It's worth 40 points. And if you do it, you're going to get 40 out of 40. So it's a little bit of a gift for some of you who need a little boosty boost for your grade. All right. Where the heck did... Oh my God, I think I signed. Oh no, wait. Where did I sign off? The heck? Oh, there I am. I thought for a minute I lost you. Sorry about that. All right. I am just a hot mess. All right. This is Professor Ken signing off. Mwah.